The moment humans created their very first weapon, the extinction of thousands of species became inevitable. That single step alone changed the fate of life on this planet forever. However, not all extinct animals are completely gone. Some of them still have close living relatives, and through those relatives, science is now trying to bring certain extinct species back. This is part 2 of this series, and I really appreciate your response on the first part. Now, let's start.
Ground sloths are related to the slow, sleepy sloths we see today. Modern sloths are roughly the size of cats and are known for being extremely lazy and slow-moving animals. But during the Ice Age, their ancestors were nothing like that. Ground sloths were enormous creatures, some of them nearly the size of elephants. These massive animals roamed across the Americas, moving on land instead of hanging from trees like modern sloths. Despite their size, ground sloths were herbivores and mostly lived in forests and grasslands. Because they lived in warmer regions rather than frozen environments, scientists have never found well-preserved frozen bodies of ground sloths. As a result, extracting high-quality DNA from them has proven extremely difficult. Since cloning them directly is not possible, the only realistic way to bring them back is through genetic engineering. Scientists plan to use CRISPR gene editing technology on modern tree sloths, which are their closest living relatives. By editing specific genes, researchers aim to recreate a sloth that closely resembles the ancient ground sloth. Then we had thylacines, also known as Tasmanian tigers, looked like a strange hybrid between a dog, a tiger, and a kangaroo. These marsupial predators once lived in Australia and Tasmania. Around 3,000 years ago, humans introduced dingoes into Australia, which created competition for food. As a result, thylacines disappeared from mainland Australia. The remaining population survived in Tasmania, but their fate was sealed when British colonists arrived. The thylacines were heavily hunted, blamed for killing livestock, and slowly wiped out. The last known female thylacine died in captivity in a zoo in 1936 due to poor treatment. The photos and videos we have today show that very last individual of the species. Despite their extinction, scientists have access to more than 750 well-preserved thylacine specimens stored in museums around the world. Some juvenile thylacines were even preserved in ethanol after being removed from their mother's pouch. Because of this, scientists successfully sequenced the complete thylacine genome in 2018. The dodo is one of the most famous extinct animals in history. Dodos evolved without natural predators, which meant they never developed fear. When Dutch sailors arrived on Mauritius Island in 1638, the dodos had no instinct to run or hide. Humans hunted them for food and also introduced animals like rats, monkeys, cats, and dogs, which destroyed dodo nests and eggs. By around 1690, the dodo was completely extinct. Unlike many other extinct species, the dodo left behind several well-preserved specimens. One of the most famous is the Oxford dodo head, which remains in excellent condition. In 2022, scientists successfully sequenced the complete dodo genome. The Nicobar pigeon, the closest living relative of the dodo, will serve as the host species. By editing its embryo using CRISPR technology, scientists aim to recreate a living dodo in the near future. Quaggas looked like a mix between a horse and a zebra, but they were actually a subspecies of plains zebras. Their front half had stripes, while the back half was mostly plain brown, giving them a very unique appearance. When Dutch and British colonists arrived in South Africa, quaggas were hunted heavily for meat and hides. By 1883, they were completely extinct. In 1987, a project known as the Quagga Project began, with the goal of bringing them back. Scientists used selective breeding on plains zebras, choosing individuals that naturally had fewer stripes. Over time, this process produced zebras that closely resemble quaggas.
So far, more than 150 quagga-like zebras have been born, and around a dozen have already been reintroduced into their natural habitats.
Woolly rhinoceroses lived during the Ice Age in extremely cold regions. To survive freezing temperatures, their bodies were covered in thick fur and they were much larger than modern rhinos. Because of climate change at the end of the Ice Age and excessive hunting by humans, woolly rhinos eventually went extinct. Even today, their remains are sometimes discovered in Siberia, preserved in frozen ground. However, despite these discoveries, scientists have not yet recovered high-quality DNA suitable for cloning. Instead of cloning, researchers believe selective breeding is the best option. The Sumatran rhinoceros, the closest living relative of the woolly rhino, already has more body hair than other modern rhinos. By selectively breeding individuals with hairier traits over multiple generations, scientists believe they could produce an animal that closely resembles the woolly rhinoceros.
Mammoths are arguably the most famous extinct animals ever discovered. While they were not the largest elephants to ever exist, their bodies were uniquely adapted to survive extreme cold. Thick fur, layers of fat, and specialized blood circulation allowed them to endure harsh Ice Age conditions. As the Ice Age ended, mammoth populations declined due to climate change and human hunting. Humans hunted mammoths not only for food, but also used their bones to build shelters. Around 10,000 years ago, mammoths went extinct, although a small isolated population survived for nearly 800 years after the pyramids of Giza were built. Frozen mammoth remains are frequently discovered in Siberia, sometimes with preserved tissue and even blood. Because of this, scientists successfully sequenced the mammoth genome in 2015. Asian elephants share about 99.6% of their DNA with mammoths, making them ideal candidates for genetic revival. By editing the remaining 0.4% of genes using CRISPR, scientists plan to create a mammoth hybrid. Through selective breeding, they aim to eventually recreate an animal nearly identical to the woolly mammoth, possibly as early as 2027. The projects to revive the thylacine, Dodo, and woolly mammoth are all being led by the same biotechnology company, Colossal Biosciences.
Now, I don't had enough dollars left, especially after my last video, but if you like the video and subscribe the channel, this time I would give my little sister a hug. That's all I could for now. So like the video, subscribe the channel, and stay happy.